Thank you, Jennifer. Thank you to all the students. Thank you for the military personnel here. My husband is a veteran of the Air Force, so I appreciate your service. So I am Kate McAfoose, Chang Robotics. We are a engineering company and robotics company. I am here in partnership with RoboCore, who has one of their autonomous mobile robots on display today. They have a booth set up outside, so afterwards, please feel free to come talk to them, ask more questions. But as you can see, we've got a robot here driving by itself. Who drinks coffee in this room? Okay. Who is a nurse or has a parent that is a nurse or has spent time in a hospital? Okay. Who buys stuff on Amazon or, I don't know, eBay, maybe eBay. Okay, let's go to Amazon. Okay. So you guys all have interacted with some of the different industries in which we try to serve. Jennifer mentioned our healthcare and our manufacturing work. Everything we do is to try and improve workforce and drive human efficiency by supporting it with what we would call cobots or collaborative robotics. And so our focus is on how do we improve production, and we do that with demo units such as the one that Paysol has running around. So has anybody been to Green Papaya or Blue Orchid or any other restaurants in town, or maybe the United Club at any of the bigger airports? You'll see these running around. And they will deliver food. In hospitals, we're delivering supplies. And in manufacturing facilities, we are moving raw materials and finished goods autonomously to free up workforce constraints. How does it work? Everything's driven on data. And the more data you have, the more you can do with it, as long as you're using it responsibly. And so by implementing robotic systems, digitizing workflows, smart sensors, we're able to start collecting more data where processes used to be very manual and you probably didn't have a lot of consistent or informative data, or what you had was so raw that it really wasn't workable or able to inform on anything. With these systems, you're now getting real-time, constant flows of data that can then be converted to whatever types of say KPIs or metrics that you need to start measuring performance, quality, time savings, etc. So I'm just going to show some examples of some of the work we've done and some of the robotics that we have implemented. This is a pretty quick one, so I'm not going to really talk over it, I'm just going to let you observe. And everything we're doing here is really in our manufacturing space. And these are robots that are moving products. So when I asked about coffee, this is actually a facility for a coffee manufacturer. If anybody likes the single serving forms of coffee, that's what you're getting out of this. Does anybody have any take on the difference between automation and autonomy? Automation is what you see on my right. That's what you call an automated guided vehicle, or an AGV. That is the first step in the process that we've been going through. It is a driverless fork truck for the most part. Now, the difference between that and what you see on the left, which is an autonomous mobile robot, similar to what's running around right here in front of me, is that while the AGV can move without a driver, it has a set path and it has a very strict and rigid line of rules that it must follow. If any one of those rules is out of place, or if there is an obstacle in its way, it will stop and it will wait for a human to come and fix it so that it can start again. They usually also operate when there are safety constraints made, like there might be a pedestrian path here, a safety rail, and then there'll be AGVs. Autonomous mobile robots, such as the one in front of me, work collaboratively with humans, meaning there are some rules of the road or guideways that it needs to follow, but it's generally able to navigate a path on its own. If something gets in its way, it will stop. It will then slowly work around that, and then it will keep going. So it's very different from automation, whereas autonomy is letting us collaboratively work with robots to get more done and to do it in less time. Another thing we're working on is how do we automate agriculture and transportation, but how are we also collecting data while doing it? So this is a version of a bean harvester, and what you'll see is all of the different sensors in the control system that we had to design the architecture for, so that we can start measuring things like soil, moisture levels, nutrient content, and we have another application in snow removal in which we have a sensor that is measuring the flow of snow coming out of the chute. And by measuring the flow of it, you can understand it's dense, is it lightly packed, how quickly do you need to keep moving the snow, or are you basically at the end and then the autonomous snow removal vehicle knows if needs to go back in charge. Another application, this is a handheld X-ray device. These come in a little briefcase. They're great if, who in here plays sports? Okay, specifically football. Anybody on the football team? Okay. So if you're in the football field and you get hurt, and everyone's like, I don't know if it's broken, I don't know if he needs surgery, we better call an ambulance, but while we're waiting, the kid is lying on the ground, probably hurt. What do? This device can be used, carried out, operated by anybody in this room, no protection needed, and it has an AI algorithm that can take up to 100 images a second, and then can be transferred right to a phone. And so as you're sitting there waiting for an ambulance to show up, somebody can be taking an X-ray, God forbid you fell and got hurt on the football field, but if you did, somebody could be diagnosing what they think is wrong while they wait for medical support to come. We have also taken this and we are applying it to a meat processing line, using that same AI-driven algorithm to identify where we can cut carcasses in order to increase the yields coming off of the bone. So you're reducing waste coming out of the manufacturing facility, creating more food to supply our communities that need to be fed. So that's currently in the works. You can see a picture there of the first prototype that we're testing. So this is our robot studio. This is set up at JU. We are partners with Jacksonville University, and we have our test center there. So for any of the systems that you saw on screen, when we have to test and debug before deploying to a site, we will set up here at JU, and that is a demo of our healthcare system, which you can go to the next one. This is a system that has been installed at a hospital, and it is, to what Jennifer was saying, it is saving nurses time. We have reduced the amount of travel that a nurse has to do by about 12% for each nurse on a shift. So that basically equates to a full-time employee per wing of a hospital. Which we are not interested in replacing nurses with robots. I will be the last one to put my hand up and say I want to go to the hospital again. I am from a robot, right? I'd like a human to do that for me. However, I would like that human to be available to give me the care while someone or something else is going and running around and doing the fetching and delivery of all the different elements of the supply chain. And then this is a demo of some of the different applications within transportation. Autonomous shuttles, everybody has heard about the E2C program here in town. Trucking is another focus that we're working on. And then everybody knows about robo-taxis and Cruise and Waymo and some of the different applications that have been going on in San Francisco. So we're here to do robots, we love it. Why am I showing you all this, specifically a room full of students? I am a civil engineer. I graduated from Syracuse University and then immediately moved out of New York into Florida. I'm now the president of a robotics company. So you think how does that work, right? Well, I have 3 little kids, just as Jennifer said. And right now, everything that I am doing is probably not something that's going to be a job for them when they get out of college, right? Everything's going to change. So whether it's understanding how to program, where it used to be C or C++ when I was in school, now it's Python and whatever else is coming. The world is rapidly evolving at a much faster rate than it was when I was your age. And so all I can say is to be able to do things like this, you need to study, stay in school, maybe less TikTok and less, I don't know what the show is, 90s, Beyonce, something or other. So I'm just here to say stay in school and listen to teachers. Thanks.